learning about the conservation of matter.
Ooh.
You each have one worksheet to fill out, and we will fill these out as we go. I have pencils for everybody. We are going to look at 3 common items and see if changing their shape changes their weight. We're going to start with this perfectly ordinary folder. That weighs 1.25. Your first question is weigh the manila folder and record the weight. So everybody find that question number 1 and record the weight, 1.25 ounces.
1.25.
We are going to take this ordinary folder and we're going to look like we're a magician, except I won't be able to put it back together. We're going to rip it in half. So you rip that piece in half and you rip that piece in half. Okay.
Oh, rip that.
Everybody rip a piece in half. Make sure you don't lose any of the pieces.
Right? I will use my
Everybody, take a look at these pieces. I need you to think about it, and I need you to predict or decide, are these pieces going to weigh more, less, or exactly the same as
exactly
folder?
the same. Because
everybody, think of your own answer and circle it on your paper.
Wait, where would you do that? Now weigh the folding piece and record the weight.
Right now we're circling more or less or exactly the same. Because we're forming a hypothesis. We are predicting what's going to happen.
Well, there's a lot more pieces now, so it should weigh more, right?
No.
No, really?
It's still the same thing. It's just ripped up.
Oh, well, the pieces are a lot smaller now, so it should weigh less, right?
No. It still has the same amount.
Oh, okay. All right. Well, I guess we better weigh it and find out.
Yes.
Okay, we're going to weigh it. We're going to see how much it weighs now.
125. Yes.
1.25 ounces.
Yes.
Now put that down on the next line. Now that we are finished with the folder, we will move on to our next substance.
Clay.
Kneaded eraser. We didn't have any clay, right? Kneaded eraser under alternate item. How many pieces of clay do we want?
5.
Count how many spaces there are.
5. 1, 2, 3, 4, 5. Yeah.
Okay. How about take a piece of clay off. Just a little piece of the kneaded eraser. Take a piece of the kneaded eraser off. Take a piece of the kneaded eraser off. Take a piece of the kneaded eraser off. Take a piece of the kneaded eraser off.
Doesn't work.
I need a piece.
Whoa.
It
does.
Okay.
It's so stretchy.
Next, take a piece of the eraser off.
What?
And you get the last piece. You can break it in 2, but it's still one piece. Now, one by one, we are going to weigh each piece and find out how much it is on the scale. Piece number 1 weighs 0.05 ounces.
Okay.
I need your piece.
Yes, mine.
Okay, let's see. This piece is really tiny. Let's see what it weighs. It's not even registering. It's so tiny.
So tiny. So that's like
It
0.
may ultimately affect the total weight.
0.00.
0.00. Now I need your piece. You cannot keep these. They already belong to somebody. Let's see if we get a weight on this.
Whose are they?
That one we got 0.05. Next I need yours. Let's see if it's enough that we get a weight. Not enough to get a weight.
It's as small as a peanut.
It's gonna be the most, but so far it's 0.05, 0.00, 0.05,
And the last piece, let's see what this one registers. This one is registering 0.20. Definitely the biggest piece.
So 5 plus 5 is 10. So it's 30.
Let's see if all of these together total out 2.3 ounces. I don't know if they will because this scale is a little bit not precise enough, but we will give it a try.
0.35.
0.35. That is really close. Probably the zeros were more like 0.1 or 0.2 and the scale couldn't read it. But the total is 0.35. I'm going to take all of the kneaded eraser that you guys used and put it back together, and I'm going to knead it into a sculpture.
She's doing some witchcraft right here.
She's not doing witchcraft right now. She's making a witch's hat. Do you know what witchcraft is?
Looks like Dumbledore's hat.
Yeah.
Dumbledore's hat.
The yellow man's hat.
Now, let's see how much it weighs. Do you think it's going to weigh more or less than the same?
Same.
Okay, mark down your prediction.
I already did it.
Okay, everybody ready?
What do you have?
0.35.
I was right.
You guys are getting ahead of this. For our last item that we are going to compare, we are going to use an ordinary cup of frosted ice. Not frosting, just he's left it in there a long time and it's covered with frost now. So, we're going to find out how much it weighs.
Whoa, it was 11.45. 11.45. That's a lot.
I'm going to melt it. We need to make another prediction. Is this going to weigh more, less, or the same?
I think
Once
less.
I melt it.
It's gonna weigh less. It's probably gonna weigh less because it's probably gonna evaporate.
Place ice cubes in plastic bag. Weigh the bag.
I'm still circling it.
We have the cup of ice here after being microwaved. It's still got quite a bit of ice in it, but it definitely has some liquid water. And let's see if it weighs more, less, or the same as the weight it weighed when it was completely iced straight out of the freezer.
The same.
11.45, exactly the same. So everybody, write that on your worksheets that it weighs 11.45. Based on the results of your measurements, were your predictions mostly right, mostly wrong? Circle which it is, mostly right or mostly wrong.
I was wrong. I was wrong.
I was wrong. I was wrong.
I was wrong.
We were wrong. We were wrong.
And so, now, from your observations about the measuring of everything, what can you say about the conservation of matter?
Matter